Okay, so we're going to look at a couple practice chemical reaction equations, and we're going to try and balance them. So let's take a look at this one right here. Okay, iron hydroxide is going to yield iron oxide plus water. Okay, so first of all, what kind of reaction is this? Not single. It's decomposition. Okay, we've only got a single reactant. Okay, so following the King method, first thing I do is I copy it down, making sure I leave blanks, put my coefficients in, find my yield arrow, and I make a line, build my wall. I'm going to list my ingredients. Now, I don't have, OH is a polyatomic, but it doesn't stay together over here. It falls apart into at least some of these oxygens. So I'm going to have to list iron, oxygen, and hydrogen all separately. The next step, I go ahead and just look at one side of the wall at a time, and I count atoms and find out what the score currently is. On this side right now, I currently just have one iron. The OH is inside this 3, so I've got 3 of everything in there. So I'm going to have 3 oxygens, 3 hydrogens. Let's come to the other side. On the other side of the wall, I have 2 irons. My total oxygens, I have to look at these here, and I have to look at this one here. So I've got a total of 4. And I have 2 hydrogens. So now I take a look and I see what is not the same on my left and right hand side. In this case, everything's broken. One of my tips is, if oxygen's everywhere, let's save oxygen for last because it can drive you crazy trying to balance it first. So do we want to try and fix our hydrogens, or do we want to try and fix our irons? I have a feeling hydrogen might be the better idea because of how they're packaged. On the reactant side, they come in packs of 3. On the product side, they come in packs of 2. So I need to find a common multiple of 2 and 3, which is what? 6. So I want to get my hydrogens both up to 6. So I'm going to take this right here, make it 2. I'm going to take this over here and make it 3. And I'm going to see what that does to my totals. So on my reactant side, it changes my iron to 2. And it also doubles these. So instead of 3 and 3, I've got 6 and 6. On my right-hand side, it changes my hydrogen to 6. My oxygens now, I've got 3, and I've got 3. Wait, that doesn't add up to 3. Let's try that again. Dork. Okay, that adds up to 6. Oh, hey, guess what? Everything's balanced. The 2s are good. I'm sorry, the Fe's are good, the oxygens are good, hydrogens are good. So I'm just going to make this invisible 1 visible. And I'm done. So 2 iron hydroxides are going to decompose into 1 iron 3 oxide and 3 molecules of water. Great place for questions. Did you get that little slip with the rules on it, or the steps? No, the little one.
That's right.
The one that you need to get a copy of. Okay. I wonder if I've got it somewhere that I've sitting out somewhere. I doubt it. I will get you one, but all it is just following the steps that's on that paper. Okay. You can try and do one that's a little bit less tricky. Let's look at let's try this one here. Okay. NH3 ammonia plus oxygen yields nitrogen monoxide plus water. Okay. So I copy down my reaction. I find my yield arrow. I go ahead and build a fence between my reactant side and my product side. I don't have any polyatomics that stay the same from left to right, so I'm just going to make a scoreboard of nitrogen, hydrogen, and oxygen. Same on both sides. On my left side of the wall, I'm going to count how many of each thing I have. So I've got 1 nitrogen, 3 hydrogens, 2 oxygens. On the right side, I've got 1 nitrogen, 2 hydrogens, 2 oxygens. So now, again, I want to check to see if each of these things have the same number. Nitrogen's good, oxygen's good, hydrogen is not, right? So how am I going to get my hydrogens fixed? Yeah, common multiple of 6. So I'm going to change the number that's right here, which is an invisible number 1. I'm going to change it to 2, which is going to give me 2 nitrogens, 6 hydrogens. On the right-hand side, I'm going to put a 3 right here, which is going to give me 6 hydrogens and a total of 4 oxygens. So hydrogen's fixed. Nitrogen and oxygen are both broken. So I'm going to save oxygen for last because it's everywhere. Let's fix nitrogen. Did I say this one would be easier? Yes. It's trickier. Cool. So I need 2 nitrogens on the right. How do I do that? Put a 2 right here, which is going to give me 2 nitrogens, and it's going to give me a total of 5 oxygens. Uh-oh, we're stuck, right? We're going to double everything because when you get stuck with even odd situation like that, you double all the things. So that's going to make this appear a 4, and a 6. Now I'm going to just double my totals on the right, which gives me 4 of those, 12 of those, and those. Over here, I've got 4 of those, 12 of those. Now can I get 10 oxygens? Put a 5 right here. 5 times 2 gives me 10. So it's 4, 5, 4, 6. Man, you missed a rotten. Picked a rotten getting this.
I know.
That's okay though.
It's all just like
It kind of is. It's not hard. Did I send you a video with how to do it?
I think so.
Okay. Double check that, and yeah, if you've got more questions about it, be sure and catch me in the advisor, and I'll be happy to do some more. Okay. Okay, so that's just a couple recaps of balancing. What do you want to talk about next? Okay. Oh, the different experiments that helped us understand the atom? All right. Okie doke. I mean, I've got listed on there what things led to what things. So I guess, do you have a specific question about any one of those, or how can I retell that? Because honestly, for that one, all of that came from a video that I had posted, and I will throw that up here real quick. Okay. If you come out to chemistry, atomic structure, and the periodic table of the elements, it's either going to be the easy version of the atomic structure notes, or I don't have a link out here to the other version of the atomic structure notes, which is just the actual video of them. But I'll be sure I think it's in Google Classroom. Okay. Rather than hearing me talk about that again, I'm already talking about that in that 30-minute video right there. So be sure and watch it. Actually, let me see if I can get a. Not going to watch it right now because that's awkward. Instead, what I'm going to do is I'm going to just put up the link. I don't know if you're going to be able to see that on the video, but it's there in that playlist. You shouldn't have any trouble finding it. Okay, and that's not me trying to weasel out of it. That's just, yeah, I mean, almost exactly what you're asking for is something on that. Anything else? Okay, so references that you can use while you're taking your test. Of course, you can use your color-coded periodic table that you made and we laminated, and it's got the chemical families on one side, it's got the energy levels on the other side. Super important you have that. You can use your ion chart, oxidation chart. For most of y'all, it's the blue paper or it's color-coded paper. Other stuff we've done, you can use your arrow diagram. You can use your Vesper chart, which is your axe chart. You can use your flow chart. Where'd you go? On this thumb? What gives, my dude? Come on. I broke the internet. I hate it when I do that. It has to do with this recording software. It hates me. Maybe it'll work. There we go. Okay, you can use your flowchart. Fudge, what's the problem? Really? So I can write up there, but I can't write up here. Really? I don't know what's happening. Yeah, it's totally not that. You have a sick mind, my friend. Okay. All right, I'm going to bring it down here. You can use your flowchart. It talks about naming and writing compounds. You can, let's see, what else do y'all have? Okay, you can use your King method. List of rules for what's going on. For balancing. Anything else? That's quite a few. Okay. So yeah, any and all of that you want to use on the test, you be my guest. Okay. If there's any of those that you are missing, let me know in enough time, and I'll try and track you down an extra copy. I'll either make more copies, or if I've got some in my stacks over here, you're welcome to take them. Okay. We almost out of time? Other gathering things. Okay, well I think I'll go ahead and call this video done then.